Here's the situation. You're thirsty. It's hot outside. And the local convenience store right down the street has a special going where that right there, this ice cold can of soda, gonna cost you 50 cents. And so, you and your friends walk into the store, 50-cent cans of drinks, and you've got a 5 spot. Tell me, how many of those drinks can you get? What we're looking at today is how to solve what are called one-step linear equations. And this includes equations in which the variable is the second add-in, which is just a fancy way of saying when the variable comes last. And so we'll be looking at those. And to provide you with sort of an example of all this, let's take a look back at our original problem, where we've got these 50-cent drinks, and I've got $5. So if I'm wanting to look at a way to solve this algebraically, if I say X is the number of cans of soda that I buy, every can of soda is going to cost me 50 cents, so I would multiply that times the X. So 50 cents times how many cans of soda I have, and this has to equal 5, because it has to add up to $5 if I'm spending all of that. So I've now produced this equation that if I can solve the equation, that is, if I can find the value of X, I will know exactly how many cans of soda I can buy. And this is the entire reason for the existence of equations that we want to solve, is there's something we want to figure out in the lines of that situation right there. And the natural way to solve it is through, or a natural way to find the answer is by solving these equations. So when we solve an equation, remember that means we're finding the value of the variable that makes the equation true. That thing we're looking for is the solution. And in the process of doing this, we're going to do something called isolating the variable. If you think about the word isolate, that means to get by itself. If a person is isolated, they may not have any friends, they don't have any contact with anybody else. In terms of an equation, getting the variable isolated means the equation will look something like this. X equals, let's just put down a number, 12, let's say. This variable is isolated. There are no other numbers or operations on that side of the equation with the variable. It could also be something that looks like this. 8 times 2 plus 6 equals y. This y is isolated. It is by itself on one side of the equation. And this is our whole goal in order to solve, because once I've isolated that, the number on the other side of the equation tells you the solution. So what I want to do is I want to use what we learned about manipulating equations and move everything around until the variable is all by itself. The ones we're going to start with are what are called one-step equations, and that one step refers to how many operations are involved in solving it. And so in a one step you will have one operation. When I say operation, remember that means addition, subtraction, multiplication, or division. And we're going to use these 4 operations are all you're going to see, and we're going to solve these one-step equations. So just one thing we have to do. Another nice thing, and this will come into play in just a second when we look at some examples of these, you can always check your work. If you're asked to solve, you should 100% of the time know if your answer is correct. Because once I have solved it, or I think I've solved it, take this equation here, 3x plus 1 equals 7, and then I'm getting the solution x equals 2. I can always check and see if that solution is right. So once I've gotten this answer, all I have to do is substitute that number in for the variable and then evaluate both sides. Remember, evaluate means turn into a number. So 3 times 2 would be 6. So I get 6. I should actually write that as a 6, huh? 6 plus 1 equals 7, and then that, of course, is a true statement, so I can see that this is the solution. Always check your work. Again, there is no excuse for not knowing if you have the right answer on this. So now, let's take a look at some examples of how we do this. We've got, in this case, the equation x plus 6 equals 19. Now notice how I am writing down the problem first, And then what I'm going to do is isolate the variable. I want to get this x by itself. So I'm going to move any terms or coefficients out of the way so that this x is all alone. So the thing that's keeping the x from being all alone is this plus 6. I know from my experience manipulating equations that I can get rid of this plus 6. I can eliminate that term by using the inverse operation. The inverse operation of addition is, of course, subtraction. But what I do to one side of an equation, I must do to the other. And so these two, because they're inverse operations, are going to cancel each other out, leaving me with just the x on this side of the equation. Over here, 19 minus 6 would be 13. And now I'm finished. I've isolated my variable. It only took one step because these are one-step equations. My variable is isolated, and the number on the other side tells me what the solution is. X is 13. And of course, I can check my work by substituting 13 in for x. 13 plus 6 equals 19. 13 plus 6 is, of course, 19. I get a true statement, which means 13 is, in fact, a solution. Let's look at another. 27 equals v minus 4. I debated whether or not to even mention this, but I might as well. It really doesn't matter which side the variable is on. Most of the time students are more comfortable with the variable on the left-hand side of the equation, but it can literally be on either one. There is nothing that says it has to be on one side or the other. So let's look at this. We need to isolate that v. We need to get it by itself. The thing that's keeping that v from being by itself is a minus 4. So we're going to use the inverse operation of subtraction to get rid of that 4. And what I do to one side, I must do to the other. 27 plus 4 is 31. Over here, these two cancel because they're inverse operations, leaving me with this solution, 31 equals v. And as I stated before, there's no reason to wonder. We can always check this. Substitute the value in for the variable. 31 minus 4 is in fact 27. And so I get a true statement, 27 equals 27, and I know I have done this correctly. Now let's look at an example that involves multiplication. Here I've got 6r equals 72. And I need to isolate again this variable, but I have a 6 with it. So in order to get rid of that 6, which is a coefficient, I have to do the inverse operation. Remember, a coefficient means you're multiplying that number times the variable. So this is 6 times r, so the inverse operation of multiplication is division, and what I do to one side, I must do to the other. So multiplying by 6 and dividing by 6, those cancel each other out, leaving me with just the r. So I've now isolated my variable, which is what I wanted to do. And 72 divided by 6, unless I miss my mark, is 12. And so now we have our solution. And just as before, I can substitute that in and check, replace the variable with its value, and then I can place 6 times 12 in my calculator. It is in fact 72, and so I can now see that I was right and that 12 is the solution. Now, one final look. We've done 4 examples. We've done addition, subtraction, and multiplication, so I hope you kind of knew what was coming here. We have z divided by 7. Don't think of it as a fraction. That's division. Z divided by 7 equals 3. And so in order to undo division, I need the inverse operation, which is multiplication. So I multiply both sides by 7. Multiplying and dividing cancel each other out. So now I have isolated the variable. I'll put that there to make it more clear. It's a z. And over here, 3 times 7 is 21. And I've now solved my equation. So we just do the opposite of division, which is, or the inverse rather, of division, which is multiplication. And as always, I can substitute 21 in for z, 21 divided by 7 is in fact 3, so alright, we've done this correctly. Now, for the last and most mysterious part of the objective, what happens when the variable is the second addend? So when addition and subtraction are going down, the variable, we're most comfortable with it being written first. However, it doesn't always happen. So here's what we do. If the number is written first, we're going to use the sign of that number to tell us what to do. So let's look at this example. I have 3 plus c equals 7. Notice the variable is in that second place. So let's look at this 3. Is that a positive or a negative 3? Well, we know it's a positive, but when it's positive, we don't necessarily write the plus. Well, let's put it in there. Now, in order to get rid of that 3 so that my variable is isolated, how do I get rid of a plus 3? Well, the inverse operation of that would be subtraction, of course. So these will cancel out, leaving me with plus c. Well, that's positive c. I don't have to write the positive part anymore. And then 7 minus 3 is 4. And so I have my solution. Again, I just used the sign of this first number to tell me what I needed to do for an inverse operation. And as always, we can check. Substitute that value back in, and we can see that 3 plus 4 does in fact equal 7. So this is our solution. This gets most complicated when you have this situation where the number out front is negative. This is where I see students have some problems. We need to isolate our variable. We need to get that plus k by itself, but we've got this minus 4 over here in the way. So how do I get rid of, eliminate a minus 4? Well, the inverse operation of subtraction is, of course, addition. So I would add 4 to both sides. 13 plus 4 would give you 17. Negative 4 plus 4 is 0. Those two cancel each other out. And now my k is isolated on that side of the equation. And so I have solved. K is equal to 17. I know what k is now. I can substitute that in to make sure that I'm correct. Negative 4 plus 17 is 13. And so I can see that I get a true statement and that I must have been correct. So let's recap now. We have here 3 different kinds of equations, and we can look at how to solve all of these. Again, in every single one of them, all we want to do is isolate the variable. So here I want to get the x by itself. So to get rid of the plus 9, subtract 9, and those cancel each other out. My variable is isolated, and I know what it's equal to. It's equal to 2. Now I can do the same thing over here. I've got 3 times x. I need to isolate that x, which means I need to get rid of that coefficient of 3. So to undo multiplying by 3, I need to divide by 3. Multiplying and dividing, they cancel each other out. My variable is isolated. 18 divided by 3 is 6. And of course I can check every single one of these by substituting it back in. And now I get down to this one, my final one. I need to isolate that x, so I have to get rid of this minus 2. To get rid of a minus 2, simply add 2. Now I've isolated the x on this side. 5 plus 2 is 7, and I have my solution.